Welcome to Module 11, AWS Compute Services. In this module, we will cover the following subject: Amazon Elastic Compute Cloud or EC2, Amazon EC2 Instance Type, Virtualization, comparing virtual machines versus Docker containers, AWS Container Services, Amazon Lambda, choosing the right hosting option on AWS, Utilization, the constant dilemma in on-premises data center, Amazon EC2 Auto-Scaling, Elastic Load Balancing or ELB. Let's get started. Amazon Elastic Compute Cloud, often abbreviated as Amazon EC2, provides on-demand, scalable computing capacity in the Amazon Web Service Cloud as Amazon EC2 instances. EC2 runs on physical host machines managed by AWS using virtualization technology. EC2 instances share the host or known as multi-tenancy with other instances through a hypervisor and ensure secure isolation between them, making EC2 instances secure and separate from each other. EC2's cloud-based infrastructure reduces hardware costs and accelerates application development and deployment. You can provision and launch instances rapidly, only paying for the compute time you use. This provides flexibility, cost-effectiveness, and easy scalability compared to traditional on-premises resources. EC2 supports both Windows and Linux operating systems, allowing you to choose the one that suits your specific needs. You gain control over software and networking settings with a variety of configuration options. With EC2, you can launch as many or as few virtual servers as needed, configure security and networking settings, and manage storage efficiently. EC2 empowers you to add capacity when you need to scale up for compute-intensive tasks or spikes in website traffic. On the flip side, you can easily reduce capacity when usage decreases, ensuring optimal resource allocation. EC2 has fundamental differences with traditional on-premises infrastructure. The old way of traditional on-premise required substantial upfront capital expenditure to purchase server hardware. This often involves a significant financial investment. Delivery delays: after the capital expenditure, you need to wait for the physical server hardware to be delivered. This can lead to delays in launching your applications or services. Installation and configuration: once the servers arrive, you'll need to install them within your data center. This includes making all the necessary configurations, which can be a time-consuming process. EC2 is the new way. With EC2, you can provision and launch instances within minutes, not days or weeks. This rapid deployment allows you to respond quickly to changing workloads or business demands. Pay-as-you-go model: Amazon EC2 follows a pay-as-you-go model. This means you only pay for the compute time you actually use. When you're done with your workload, you can stop using the instances, and you won't be charged when they're not running. Cost savings: EC2 offers cost savings by ensuring you pay only for the necessary server capacity. This flexibility allows you to optimize your expenses and reduce the total cost of ownership. AWS offers a diverse range of instances tailored to various workloads, categorized into general purpose, accelerated computing, compute, memory, and storage optimized types. Let's break down this complexity by looking at a specific instance type, the M5D.extra large. Consider the M5D.extra large instance as an example. Every EC2 server encompasses 4 key computing resources: CPU, memory, networking, and storage. Workloads differ in their resource requirements: some are CPU intensive, others memory intensive, and so on. To address this diversity, AWS introduced instance families, denoted by the letter M in this context. As EC2 evolved, AWS introduced instance generations to showcase innovations. In the example, the 5 represents the generation, revealing advancements in technology. Furthermore, AWS added extra capabilities denoted by the letter D. These capabilities include enhancements in CPU, memory, and networking features. The last component is the sizing of the instance, represented by the extra large in this case. It's essentially the t-shirt sizing of your instance. It's crucial to note that every instance size within an instance family maintains the same CPU ratio. However, each size doubles the number of CPU, memory, and storage resources compared to the previous size. EC2 provides a range of instances tailored to specific workloads, each designed to meet unique computational needs. Let's unravel the specifics of these Amazon EC2 instance types and explore their ideal use cases. First up, we have general-purpose instances. These provide a balanced mix of compute, memory, and networking resources, making them versatile for a variety of workloads. Whether you're running application servers, gaming servers, back-end servers for enterprise applications, or handling small to medium databases, these instances offer a well-rounded solution. Next on our list are compute-optimized instances. These are tailored for compute-bound applications that thrive on high-performance processors. Think of scenarios like high-performance web servers, compute-intensive application servers, dedicated gaming servers, or batch processing workloads that demand processing many transactions in a single group. Moving on to memory-optimized instances. These deliver fast performance for workloads that process large datasets in memory, requiring substantial data preloading before application execution. Examples include high-performance databases or workloads involving real-time processing of large amounts of unstructured data. Now, let's explore storage-optimized instances. These are perfect for workloads demanding high, sequential read and write access to large datasets on local storage or high IOPS or input/output operations per second. Think of use cases like distributed file systems, data warehousing applications, or high-frequency OLTP, the online transaction processing systems. Last but not least, we have accelerated computing instances. These leverage hardware accelerators or coprocessors to execute specific functions more efficiently than traditional CPUs. Examples include graphics applications, game streaming, and application streaming, showcasing the power of specialized hardware for tasks like floating point number calculations, graphics processing, and data pattern matching. Virtual machines and Docker containers are both technologies used for virtualization, but they operate at different levels and have distinct characteristics. Containers and virtual machines have similar resource isolation and allocation benefits, but function differently because containers virtualize the operating system instead of hardware. Containers are more portable and efficient. Virtual machines is a traditional hardware virtualization. VMs abstract the physical hardware of a server, effectively converting a single physical server into multiple virtual servers. This allows you to run multiple isolated instances on a single host. Each VM includes a complete operating system, application, and all the required binaries. This comprehensive packaging approach means that VMs can occupy tens of gigabytes of storage space. VMs can be slow to boot up and consume a significant amount of resources due to their individual OS instances. Docker containers virtualize at operating system level. Containers are app layer abstractions. They virtualize the operating system rather than the underlying hardware. This means you can package code and dependencies into a single container, which simplifies application deployment. Containers provide consistent application environments, reducing debugging time and eliminating discrepancies between computing environments. This makes application development and deployment more efficient. Containers share the host's OS kernel, making them highly resource efficient. They are much lighter in terms of resource consumption compared to VMs. Container images are compact, often occupying only tens of megabytes, making them highly portable. This portability enables you to efficiently manage and deploy multiple applications across different environments. So, when do you use virtual machine versus container? Below are some key factors to consider and the practical applications when choosing between virtual machines and Docker containers. If your application has specific dependencies tied to a particular operating system, using a virtual machine with the desired OS may be necessary. For workloads that require significant CPU, memory, or storage resources, virtual machines can provide the necessary isolation and dedicated hardware. If you need fine-grained control over the operating system, such as specific kernel-level configurations, VMs offer greater flexibility. When dealing with legacy applications that no longer run on modern operating systems, virtual machines can be used to maintain compatibility. In cases where different applications have diverse operating system requirements, using a single underlying physical infrastructure with VMs can help manage these variations efficiently. For applications or services with lightweight resource demands, or in a microservices architecture where each component is small, Docker containers are a more efficient choice. When deploying across a distributed physical infrastructure, including cloud-based servers or edge locations, containers offer agility and rapid scaling capabilities. If your organization values quick and agile deployments, Docker containers excel because Docker files, used to define container images, are easier to manage compared to VM configurations. Containers are well suited for applications that require rapid scaling up or down based on fluctuating demand. Their fast startup times make them ideal for this scenario. AWS provides a comprehensive suite of container services that encompass registry, orchestration, and compute management, delivering a secure and efficient platform for your containerized applications. In the realm of container registry, we have Amazon Elastic Container Registry or ECR, a fully managed solution that streamlines container image storage, management, and deployment for developers. For container orchestration, AWS offers 3 robust choices. First, Amazon Elastic Container Service or ECS is a fully managed orchestration service designed for the secure, reliable, and scalable deployment, management, and scaling of containerized applications. Second, Amazon Elastic Kubernetes Service or EKS is a fully managed Kubernetes service that provides a similarly secure, reliable, and scalable platform for running containerized applications through Kubernetes. Additionally, AWS provides Red Hat OpenShift service on AWS or ROSA, a fully managed application platform equipped with an array of development tools and services. In the realm of compute, AWS presents several options. AWS Fargate is a serverless compute engine tailored for containers, offering a simplified experience for application development and compatibility with both Amazon ECS and Amazon EKS. Amazon EC2 allows you to run containers on virtual machine infrastructure, providing full control over configuration and scaling. Lastly, AWS App Runner is a fully managed service designed to facilitate the swift deployment of containerized web applications and APIs, offering scalability and ease of use without the need for prior infrastructure expertise. Amazon Lambda is a powerful serverless compute service that allows you to run your code without the need to concern yourself with server provisioning or management. With Lambda, you only pay for the compute time you use, making it ideal for a wide range of applications and back-end services while eliminating administrative overhead. Here's how it works. Begin by uploading your code to AWS Lambda, or you can write your code directly in Lambda's integrated code editor. Configure your code to be triggered by specific events from sources such as AWS services, HTTP endpoints, or mobile applications. AWS Lambda executes your code in a highly efficient manner, running it only when triggered and utilizing just the required compute resources. The cost is associated with the exact amount of compute time your code consumes, ensuring you pay only for what you use. This cost-effective approach makes Lambda a compelling choice for various applications and services, allowing you to focus on your code while AWS handles the infrastructure details. Selecting the appropriate hosting option on AWS can significantly impact your application's performance and manageability. Here's a straightforward decision tree to help guide your choice. Are you hosting traditional applications that require full access to the underlying operating system such as Linux or Windows? If yes, consider Amazon EC2. If not, proceed to the next step. Are you hosting short-running functions, service-oriented, or event-driven applications that do not require any management of the underlying environment? If yes, AWS Lambda is an excellent choice. For other scenarios, continue to the next question. Are you planning to run Docker container-based workloads on AWS? If yes, move to the next step. Do you need container orchestration? If yes, you have 2 options. Amazon ECS for a straightforward container management solution. Amazon EKS if you prefer to use Kubernetes for container orchestration. Now, you have a choice between running containers on EC2 instances that you can manage yourself or opting for a serverless environment that is fully managed for you. If you prefer to manage your EC2 instances, go with Amazon EC2. If you want a fully managed, serverless environment for your containers, AWS Fargate is the way to go. By following this decision tree, you can make an informed choice about the hosting option that best suits your specific application needs and preferences. Balancing hardware resources in an on-premises data center can be a constant challenge. The dilemma often revolves around optimizing utilization without compromising customer satisfaction. Here's the explanation. Your dilemma when buying for average load. Purchasing hardware resources based on average usage helps prevent unnecessary expenditures during typical workloads. It's a prudent cost-saving strategy for businesses. However, there's a catch. Peaks in demand can occur, especially during critical moments. If you've tailored your infrastructure solely for average usage, you might find yourself with insufficient hardware during these high-demand periods. This can lead to a decline in customer service quality, impacting overall satisfaction. The dilemma of buying for peak load. It's essential to keep customers satisfied during peak periods of high demand. However, a significant challenge arises when resources are kept idle for the majority of the year due to this approach. In many instances, average resource utilization can drop to less than 10% as businesses maintain excess capacity out of fear of not meeting peak demands. This scenario poses its own set of problems, balancing customer satisfaction with resource efficiency. With Amazon EC2 auto-scaling, you can say goodbye to the dilemma of buying for average or peak load. Amazon EC2 auto-scaling is a service designed to address the challenges of scaling resources to meet changing demand, ensuring the availability and performance of your applications. It dynamically adjusts the number of Amazon Elastic Compute Cloud instances, adding or removing them based on predefined scaling policies. There are two key aspects of Amazon EC2 auto-scaling. Dynamic scaling. This component allows resources to be adjusted in real time, responding to changes in utilization. It employs target tracking scaling policies to maintain specific utilization levels. For instance, if you set the CPU utilization target at 75%, and it exceeds that threshold, tasks are automatically added to accommodate the increased workload. Predictive scaling takes a proactive approach using machine learning to forecast workloads. It generates scheduled scaling actions, adding or removing Amazon EC2 instances based on predicted demand. This ensures that resource utilization remains in line with the specified target value, such as maintaining average CPU utilization at 50%. Proactive scaling helps handle unexpected traffic spikes and maintains a balanced utilization level. Amazon EC2 auto-scaling allows you to set the minimum, maximum, and desired capacity for each auto-scaling group. An auto-scaling group is a collection of EC2 instances that are managed as a unified entity for automatic scaling purposes. Minimum capacity. This represents the initial number of Amazon EC2 instances that are launched immediately upon creating the auto-scaling group. For example, it can be set to 1. Desired capacity. This is the target number of EC2 instances that you want the group to maintain. For instance, you can set it to 2. Maximum capacity. This defines the upper limit or maximum number of EC2 instances that the group can scale out to. For instance, you can set it to 4. It's important to note that if you don't specify a desired number of Amazon EC2 instances in an auto-scaling group, the desired capacity will automatically default to the minimum capacity. Amazon EC2 auto-scaling leverages Amazon EC2 instances, ensuring that you only pay for the instances you use. This cost-effective approach enhances the customer experience and helps reduce expenses, as you are billed based on your actual resource consumption. Elastic Load Balancing or ELB is a powerful service that automates the distribution of incoming application traffic across multiple targets and virtual appliances, all within one or more availability zones. Here are some key points to understand about ELB. ELB automatically spreads incoming traffic across various resources, such as Amazon EC2 instances, creating an efficient load distribution system. Acting as a central hub for incoming web traffic, ELB provides a seamless way to ensure even distribution to your auto-scaling group. By distributing requests evenly among multiple instances, ELB prevents any single instance from becoming overloaded, resulting in a smoother and more responsive application. ELB and Amazon EC2 auto-scaling work together to optimize application performance and maintain high availability, effectively handling fluctuations in traffic demand. During periods of low demand, a limited number of Amazon EC2 instances handle incoming traffic while ELB ensures that instances don't sit idle. This dynamic approach ensures efficient resource utilization and cost savings. When traffic surges during high demand periods, ELB dynamically scales up Amazon EC2 instances to efficiently manage the increased load. ELB plays a crucial role in directing traffic across Amazon EC2 instances, ensuring that resources are used optimally and efficiently. The combination of ELB and Amazon EC2 auto-scaling provides a flexible and scalable solution that helps maintain optimal application performance under varying traffic conditions. Congratulations! You have completed Module 11. AWS Compute Services.